Rahim. Hello everybody, this is Amir. Welcome back to the second tutorial of Hadoop. Last tutorial we learned about big data. I know you have got basic idea about what is big data. Now move on to the second tutorial. In this tutorial we'll learn about basics of Hadoop. Many of you have heard about Hadoop. What is Hadoop? You have heard many times, maybe you have heard of Hadoop many times, like, but you don't know what is it. Now in this tutorial I will give a basic introduction about what is Hadoop, what are the things involved in it, what it does, what are the links between the Hadoop and big data, what is the relation between Hadoop and big data. All these things will you get to know in this tutorial. If you have any queries regarding the previous tutorial, please comment below. Now let us explore about Hadoop, like basic introduction of Hadoop. Before going to Hadoop, let us recap what we have learned before. We have learned before about big data. What is big data? I have said earlier that the term itself suggests that the data is huge. It may be around TBs of data. With the advent of new technologies, as we have new technologies evolving day by day, year by year, like social networking sites like Facebook, the amount of data that is generating is very huge. The data being generated is 8 million, is in terabytes, hundreds of terabytes. Facebook generates nearly 500 terabytes per day. Where does all this data goes? The amount of data produced by US from the beginning of time 2003 was 5 billion GBs. Let us think, if you make all those data in the form of a disk and arrange, then all will occupy entire football stadium. See how big the data is, how large the data is. The same amount was created every 2 days in 2011. As I have said earlier, the data is increasing exponentially. This is the result. From the past years, the data has increased to 5 billion gigabytes. Now it is increasing that amount of data in only 2 years. Let's move on to further. Before knowing about Hadoop, HDFS is Hadoop Distributed File System. Before knowing about Hadoop Distributed File System, we will have to know about what is a file system, what is a distributed file system, and then we will go to Hadoop Distributed File System. Now, what is a file system? File system is the structure a computer uses to organize data on the hard disk. Every computer has a hard disk. It needs to organize the data in the hard disk. For that purpose, the operating system has a file system for that. If you are installing a new hard disk, what you do? You make it into some partitions and then you use the hard disk. Why you make partitions? Because you want to store data or programs, whatever you want in that. So that is the file system. File system is every computer needs to adopt a system for storing its information. That is called file system. Now, let's discuss about distributed file system. Distributed file system is a client-server based application. What it means is the data is stored in different systems, not only a single system. The whole data is divided and it is stored in different systems in small amounts. If the data is very huge, it is stored in very large amounts in different systems. We have a It's a client server based application. What it means? One system is used to access all other systems. That is called client and server. How to solve big data? Up to this we have seen about what is file system, what is distributed file system. Now we will see about how to solve big data. These are some of the solutions to solve the issues related to big data. Here this is a traditional approach. Here what we do is, let us take in traditional approach, in a company uses a computer to store and process data. If you have data, what you have to do? You have to store the data and you have to process it parallelly, right? In traditional approach, we use a computer to store the data and process. In that, what we do is, we use some softwares like Oracle, database vendors such as Oracle to store the data, and in this approach the user interacts with the application in turn, which handles the part of the data storage and analysis. By storing the data in the database like Oracle, we process the data in the traditional system. Now let us come to Google's system. What Google has found? Google has found a solution for this. They developed an algorithm called map-reduce. Map and reduce are the two different functionalities. Let us not go into in detail here. We will discuss this in the future. Just remember the word map reduce. Google uses this concept to solve the big data. What this algorithm does is, it divides the task into smaller parts and assigns to many computers. Let us suppose we have data consists of 10 GB. What it does is, we have 5 systems. It splits the data into equal parts, or it may be unequal, like 2 GB in one system, 2 GB in other. Like in 5 systems, it stores the data. That is what Google has provided. This is Google solution. Now Hadoop. Let's come to Hadoop. We have discussed about file system, distributed file system, and the solutions to solve the big data problems. Now let us discuss about Hadoop. Listen carefully. Please pay concentration here. You need to pay concentration so that you understand it perfectly. Let us go. Using the solution provided by the Google, this MapReduce algorithm, Duff Cutting, what he does is, he and along his team develop an open source project called Hadoop. They adopted the Google file system and they developed open source project called Hadoop. Hadoop uses the MapReduce algorithm, in which the data is processed parallelly across different systems. Hadoop is used to develop applications that could perform complete statistical analysis on huge amounts of data. What it means? It has several applications which are used to perform analysis on huge amount of data, which is in terabytes, petabytes, exabytes. Remember, exabytes, petabytes and terabytes. Why distributed file system? Let us understand this. See here. Let us consider this system. This machine, let us consider, has 4 I/O channels, that is 4 hard drives. Assume each channel processes the data at 100 MB per second. Let us note one point here. Data storage is not at all a problem. Nowadays you have 4 TB of hard disk, external hard disk, 3 TB, 2 TB. Data storage is not at all a problem. Here the problem is, what is the problem? here the problem is processing of the data. Processing of the data is the major problem here. Let us understand this. We have 1 TB of data to be read. Let us consider this. We have one machine in which we have 4 hard disks, 4 hard drives. Each hard drive processes data at 100 MB per second. Calculate this. The time taken to process the 1 TB data is 45 minutes here. If you take this, what here we have done, we have distributed the 1 TB of data into multiple systems so that the processing happens parallelly and the result is obtained in very less time. See here it took 45 minutes to process the data in a single system, whereas if we split the data in different systems, we took here 10 systems, we distributed the data across 10 systems and we processed it parallelly so that the whole task is accomplished in only 4.5 minutes. See what the difference in the time is. The processing time has reduced to a great extent. This is the importance of distributed file system. I hope you understood. If you want, I will go in detail about this in next coming tutorials. Let us move further. What is Hadoop then? Let us understand this definition. Apache Hadoop is a framework that allows for the distributed processing of large data sets across clusters of commodity computers using a simple programming model. Do you understand what it means? I think many of you have understood this, but let me explain this. Apache Hadoop is a framework. What is meant by framework? Framework is nothing but a base or a software. Apache Hadoop is a tool or software. What it does? It allows for the distributed processing of large data sets across clusters of commodity computers. Here, distributed processing of large data sets. What Hadoop is for? It's not for small data sets like what we have, like 1 GB or 2 GB data. It is for processing large data sets. How much? 500 GB, 500 TB of data. For processing that much huge data, this Hadoop framework will be used. It allows the processing of that much huge data across clusters of commodity computers. What is meant by clusters? Let us now understand what is meant by commodity computers. Commodity computers means cheap computers which comes for less cost. That is called commodity computers. See, what is a cluster? Look here, each and every word has its meaning. Here, let us understand what is a cluster. Cluster is simply group of nodes. You may get a doubt what is node. So let us not go this into depth. We'll discuss about node in further slides. Let us understand clusters is group of nodes of commodity computers. Why commodity computers? Commodity computers are cheap computers. Why should we use cheap computers? Because as we are storing large amount of huge data, we can't spend much money on that for storage. What we have to do? We have to take cheap hardware, cheap computers for storing the data. And why cheap computers? We will discuss this in the future slides. How to process this data? What we do to process this data? We use simple programming model. What is this programming model? There are many programming models, but the basic is MapReduce. We will discuss about this in the further tutorial. Let us not go deep into that. Let us move further. It is an open source data management with scale out storage and distributed processing. See here, this is a very important point here. Do you know what is scale out storage? It means that there is no limit for storage. You can store any size data can be of any size. You can here the system is scalable. It means you can add any number of systems, any number of nodes for storing the data. Here, why should we use less commodity hardware? You would get it out what happens if the hardware fails. Here, what we do is we replicate the data here. Let's not go further into that. Let us move into the next tutorial, next slide. Let's understand what are the key characteristics of Hadoop. See, these are the 4 key characteristics of Hadoop. First one is reliable. It is reliable. How is it reliable? The data is stored in different computers and the replication of data is also done, so there is no loss of data. And economical, as we are using the cheap hardware, commodity computers is nothing but cheap hardware, it is economical. Scalable, as I have said that it is scalable. How is it scalable? We can add any number of nodes in Hadoop distributed file system. Here, flexible. It is easy to program and to analyze the big data using Hadoop. Thus, it is flexible. Let us move further. Hadoop ecosystem. Hadoop, look here. Please concentrate. Hadoop ecosystem. See here, Apache Uzi. What it does is it provides. Let us move from bottom. Here we have unstructured data and structured data. As I have said in the previous tutorial, what is unstructured data or structured data? What is structured data? The data which can be stored in the form of tables is structured data. What is unstructured data? The data which is obtained from media files, audio files, images is unstructured data. And what is semi-structured data? XML files are semi-structured data. Let us look here. Flume, scoop. What is Flume? What is scoop? Flume is if you want to import the data from HDFS to your local Oracle, to your Oracle software, what we do is we use Flume and scoop for importing and exporting. Let us discuss this in the further tutorial. Let us move on. We have double layer, we have Hadoop distributed file system. About that, we have MapReduce framework. This MapReduce framework is very important. This is the basic framework which is involved in processing big data. We have Hive, Pig Latin and Mahout. We will discuss this in the future tutorials. Please don't get confused here. Let's move further. I will give you a real-time example here. Machine learning with Mahout. What is Mahout? Let us not discuss what is Mahout, what it does. Let us understand a basic example. How many of you have LinkedIn accounts? If you do have LinkedIn account, you may have seen some LinkedIn recommendations like companies you may want to follow, jobs you may be interested in. How all these happens is due to Mahout. How it happens we will discuss in the further tutorials. Let us concentrate here. We are going somewhat deep into the Hadoop distributed file system. See here, MapReduce engine HDFS cluster. Please concentrate here. See, job tracker, you are seeing something called job tracker, task tracker, admin node, name node, data node. What is this? See the name here, job tracker. What do you understand by this? First, let us understand what is job tracker, what is name node, what is data node, what is tracker. Just remember, how many of you know about what are daemons? DAEMONS. Let's. Daemons are the background processes, background services which are running in the background. You can't see daemons. So, these job tracker, task tracker, name node, data node are daemons. They won't be visible to you, they will be running in the background. What is job tracker? The name itself suggests that it tracks the jobs. The main responsibility of job tracker is to handle the jobs given by name node and assign it to task tracker. See here, it takes the job and assign it to task tracker. Then what is task tracker? It takes the job assigned by job tracker and it performs the job. What is admin node? What is name node here? Here the name node is acts like a root node. What is a node? Do you understand what is a node? Node is nothing but a system, a computer. Node is nothing but a computer. See here, name node. It is the basic node. What it does is, it takes the jobs given by the client. Client is nothing but the software. Whatever the jobs given by the software, it takes and it stores the metadata of that and it assigns the job tracker. It asks the job tracker for performing the task. Here, job tracker assigns the jobs to different task trackers. Task trackers allows the data node to process the task given by the admin node. Here, whatever the data is given, that is stored in blocks. What is a block? Block is a physical division. Physical division of the data. Let us assume we have 100 GB of data. It divides the data into 64 MB blocks. Why only 64? May not be only 64, it can also take 128 MB. Whatever the data you give, that is stored in blocks in every data node. Each block may be of 64 MB or 128 MB. You may think that what happens if this name node fails? What happens? If this name node fails, then the entire data will be lost, isn't it? What we have to do? For that purpose, this name node should be of high reliability. It should possess high reliability. Why high reliability? Because it shouldn't get, it is a single point of failure. What do you mean by single point of failure? If it fails, the entire data will be lost. It stores the metadata. So it should be of high reliable node. The other nodes can be of cheap hardware. It can be of cheap computers. Why cheap computers? Here we do the replication of data. What is replication? Replication is nothing but duplication of the data. The data is duplicated and stored in minimum 3 nodes. Why minimum 3 nodes? Minimum 3 nodes because It's a minimum standard given by Hadoop. It should have minimum 3 replications, because if any one node loses the data, then we can access the other node for processing the data. Let us go further. This is the architecture of HDFS. Let us see here. Name node. First, name node stores metadata. What is metadata? Metadata is nothing but data about the data. Data about the data means if you store the data in the data nodes, what name node contains is the address of this data. It stores where the given data is stored, in which node the given data is stored, in which cluster, in which rack it is stored. Suppose let us take an example. We have two nodes, one in Hyderabad and another in Mumbai. What you store the you split the data and stored in two different nodes, and one in Mumbai, one in Hyderabad. What this name node contains is the address of the node present in Mumbai and the address of the node present in Hyderabad. That is called metadata. Here we have data nodes. This you are seeing this yellow rectangles. These are called data nodes. These are replicated. See here. What are the things we see here now? Client. What is client? Client is nothing but whatever the software you are using for, whatever the application you are using for performing this is client. And the main problem here is storage is not really a problem. Reading the data is a major problem. So we need to avoid that. Let us move further. What are the main components of HDFS? As I have said in the previous diagram, it is name node and data node. Name node is called the master of the system. Why master of the system? Because it maintains and manages the blocks which are present on the data nodes. What is meant by maintaining and managing? The data which is present is stored in data nodes, and it is also replicated. It is a master system because it is the responsibility of this name node to distribute the data across different clusters, across different nodes, to store it and store the metadata of it, and to assign the job. You are seeing this car here and this ambassador here. What these both represent, it is the costliest car and is the cheapest car, right? This car is composed of very high features, whereas this one has less features. In the same way, our name node should be of high reliability. It should be of high quality, so that it is a single point of failure, so that it should not be get destroyed. So it should be of maintained of high quality. Let us see here data nodes. What are the data nodes? These are the data nodes. This is the master and data nodes is the slave node. These nodes are deployed in each and every machine and which actually stores the data. This data node is only responsible for storing the data and serving the request for the clients. Whatever the request made by the client is served by this data node. Metadata. What is metadata? I have already said that it is the data about the data. The entire metadata is in main memory. The entire metadata is stored in main memory. Types of metadata, kinds of what what can metadata contain? It can have list of files, list of blocks for each file, list of data nodes, file attributes, for example, access, replication factor, access time and replication factor. What is replication factor? Replication factor is for each file how many replications you are doing. That is the replication factor. And transaction log, record file creations, file deletions, etc. See here, name node, it stores only metadata, not the actual data. This is the metadata. See here, slash user slash the slash hinfo 135. Here the one point you need to remember is what we do actually here is we store the data in HDFS, we process the data. How we process the data? We don't get the data from different nodes to local system and then process the data. If you do that, that's impossible task because the data is very huge. It is such a huge data that it is in 500 to 1000 TB. It is impossible to get the data from different system to our system and then process the data. It's a impossible task because the huge there will be usage of huge bandwidth. What we do is we write a small program, we send our code to the data node, we then process the data and then get the results from there. Then this is the perfect technique for processing the data. That is why Hadoop is evolving day by day. Understand? If you don't understand, if you have any doubts, please leave the comments below. Let's move further. Secondary name node. What is secondary name node? You may have come across primary name node, that is admin node. Secondary name node. Here there is something called secondary name node. What it does is it backups the data metadata present in the name node from time to time, because if at some time it fails, then there will be a checkpoint for them to restart that. There is a misnomer that many people think that in Hadoop, if the name node gets failed, then the secondary name node acts as name node, main name node. No, this is absolutely wrong. In the very first version of Hadoop, if you move further to the second version of Hadoop, we have something called active name node, passive name node. Active name node is a main admin node. If it gets failed, then the passive name node acts as the active name node. That is in the second version of Hadoop, but this is not possible in case of first version. In the very first version of Hadoop, the secondary name node, what it does is connects to name node every hour. See here, secondary name node, what it does, it asks, give me metadata every hour, I will make it secure. It makes a backup of the data time to time. That is the role of the secondary name node. Let us understand what is job tracker. We have discussed about primary name node, secondary name node, and job tracker. What are these? I have said already that these are the background services or daemons. Now job tracker. What is job tracker? See, observe carefully here. User submits the job to client. Client is what is the software we are using. First, what user copies the data into Hadoop distributed file system using there will be some commands, Linux commands. By using that, user copies into HDFS. After that, user submits the job into client. Client is a software which will be used in HDFS. After that, whatever the input file present in HDFS, it gets the information about those files. This client gets the input information which are present in the Hadoop distributed file system. After that, what it does is it divides the whole data into certain splits. What are splits? I've said actually already that the data is stored in the form of blocks of 64 MB. That is the physical division. Here, splits are actually the logical division. Here, the input data is splitted into several splits, input splits, and jar files are created from that, and after that, job is submitted to the job tracker. Let us move further. Client submits the job to the job tracker. Job tracker initializes the job in the job queue. There is something called job queue. Whatever the jobs that is being assigned by the job tracker is stored in a job queue. From the job queue, each and every data is processed. And what are the files that are required for performing the job are obtained from Hadoop distributed file system. And after creating the input splits here, that their map jobs and reduce jobs follows. I will understand what are map and reduce jobs in further tutorials. Let us just remember that how many input splits are created, that many map jobs are created, because at every input split we need a mapper to map that input, process that input. Here we have job tracker. How job tracker knows that task tracker is idle and it is alive and it can be assigned a job. It is free and it can be assigned a job. How? Here task tracker sends some signal called heartbeat to the job tracker. By sending that, it acknowledges that I am free or I am alive, you can assign job to me, I am ready to perform the job. After receiving the heartbeat, the job tracker knows that this task tracker is free now and it assigns the required job. HDFS picks the jobs that are there in the job tracker and performs MapReduce task on that. After completion of this task, job tracker, what it does is it assigns another task to the task tracker. After completing, it again sends heartbeat. This heartbeat is sent time to time for saying that the job tracker is alive. Every job tracker sends heartbeat at regular intervals of times to the job tracker, so that it will be easy for the job tracker to know that when to assign jobs to which task tracker. Here, replication and rack governance. We will discuss this further in further tutorials. Let's just have a brief introduction about this. We have three blocks A, B, C. One is in red color, blue color, and green color. You may have questioned that the same type of nodes should be in same rack. No, it's not that the same type of nodes should be in same rack. You can have different combinations of nodes in different racks. Rack is nothing but you have certain clusters. You have group of clusters is nothing but rack. You have certain clusters, and the clusters are stored in different places. Like assume this cluster is in Hyderabad, this is in Mumbai, this is in Bangalore. We have one cluster in Hyderabad, one in we have a data node in one in Hyderabad, one in Mumbai. It's not necessary that the two same data which belongs to the same input has to be in the same rack. They can be in different racks. So this is the conclusion of today's lecture. Let us discuss more concepts in the further tutorials. Please leave the comments below if you have any doubts. Please subscribe to my channel and please do like. If you have any suggestions, feel free to suggest. Thank you and Assalamu alaikum wa rahmatullahi wa barakatuhu. Bye.